Hello guys, in this tutorial I'm going to solve the question number 9, paper 33, June 2022. With respect to the origin O, the point A has position vector given by OA is. The line L has vector equation or is. Find and degree the acute angle between the direction of OA and L. In general, how to get the angle between two vectors? If we have vectors OA, vector OA, and the line L, I will get it the angle between the vector OA and the vector of the line. The vector of the line is negative I and plus 2j and 3k. And OA is 1i plus 5j and 6k. To get the angle in general between vectors A and B, cosine theta is equal to A dot B over magnitude of A and magnitude of B. The dot product shift cosine theta is equal to the dot product, which is x1 x2 plus y1 y2 plus z1 z2. Negative 1 times 1 is negative I, then x, y with y, 2 times 5 is 10, 3 plus 3 times 6 is 18, over magnitude of first and the magnitude of second, 1 plus 4 plus 9, 1 plus 25 and 36. Shift the cosine, the numerator simplified is 10 times 10, 28 will be 27 over magnitude of first and magnitude of second. Shift cosine, 27 divided by square root of 1 plus 4 plus 9 multiplied by square root multiplied by square root of 1 plus 25 plus 36. So this angle in red, but it's better to write it in degrees if it is not mentioned in degrees for red. So the answer will be 23.6 degrees corrected to 1 decimal place. This is part A. Part B, find the position vector of the foot of the perpendicular from A to L. We have equation of line L, and this is the point A, where is coordinates of A, the position vector of A, given 1, 5, 6. 1, 5, 6. Let's say the foot, the projection of the point A is Q. Step number 1, find OQ in terms of T, because it's on the line L, and we already have the equation of line L, so it will be 4 minus lambda. 4 minus lambda, this is x. For y, 1 plus 2 lambda, 1 plus 2 lambda, 1 plus 2 lambda, and 0, sorry, it's j, so 0, this is 0, it's not 1, this part is 0, but k, 1 plus 3 lambda, 1 plus 3 lambda. This is OQ in terms of L, the coordinates of Q in terms of L. Then OAQ, we'll try now to get AQ as a vector, will be OQ minus OA. OQ, we already have it, 4 minus lambda, 2 lambda, 1 plus 3 lambda. Dot OA is 1, 5, and 6. So to get AQ, second minus first, it's a minus. So the answer will be 4 minus lambda plus 1 is 5 minus lambda, 2 lambda minus 5, and 1 plus 3 lambda minus 6, it's minus 5 plus 3 lambda. Now, the relation between the vector AQ and the direction of line are perpendicular, so the dot product is equal to 0. So the vector AQ dot direction of the line, which is minus 1, 2, and 3, minus 1, 2, and 3, minus 1, 2, and 3, their product is equal to 0. So I will use directly this part is equal to 0. The dot product is equal to 0. Solve the equation to get lambda. So now 5 minus lambda, 2 lambda minus 5, minus 5 plus 3 lambda, dot negative 1, 2, 3, minus 1, 2, 3. So the answer is minus 5 plus lambda, then 2 plus 2 is 4 lambda minus 10, then minus 15 plus 9 lambda is equal to 0. Lambda 4 and 9 is 14 lambda, minus 5, minus 10, minus 15, minus 30 is equal to 0. So lambda is equal to 30 over 14. Then, now we can find the coordinates of OQ, or the position of OQ now, of course, substituted by lambda, which is 30 over 14. 30 over 14. I think this is 1 plus 4 lambda first, negative 5, negative positive. So 2 by 2 is 4 minus 10, 3 negative 5, negative 15, 3 by 3, 9. So 4 and 1, 5 is 14. Let me check. If it is fraction, we'll revise. If it's okay fraction, so keep it. OQ is 4 minus 1 lambda, 4 minus 1 lambda, correct. For y, 0 plus 2 lambda, correct. And 1, 3 lambda, correct. This is OQ. For OA is 1, 5, and 6. 1, 5, 6, correct. So OA, we'll find first the vector OQ, second minus first. 4 minus lambda minus 1 is 3. Yes, we have here mistake. 1 minus 1, this is 3. 2 lambda minus 5, correct. 1 plus 3 lambda minus 6 will be negative 5 now, it's correct. So this is 3 is not 5, will be 3. So the product, this one will be negative 3. So negative 3, negative 1, negative, negative is positive lambda. So negative 3. Now 1 plus 4, 5. 5 and 9 is correct, 14. Minus 3, minus 10, minus will be minus 28. Minus 28. This is now will be plus 28. So 28 divided by 14. So the answer will be 2. Back to OQ now and remove y and write 2. So 4 minus 2 is 2. And y coordinate 2 by 2 will be 4. And x 3 times 2, 6 plus 1 will be 7. So the coordinates for the position vector of OQ is 2, 4, and 7. Hence, find the position vector of the reflection of A and L. Now, in case if this line is L, this point is A, this point is A 156, 156, and Q, let's say this point Q, 2, 4, 7, 2, 2, 4, and 7, 2, 4, and 7. To be reflect, we have to extend this point on the other side perpendicular and equal in distance. So the point Q represents the midpoint. Let's say the reflection is A dash. So let's say the coordinates X, Y, and Z. I apply the midpoint X1 plus X2 divided by 2. Let's say same Y1 plus Y2. Now, if this is X, which is 2, equal 1 plus X divided by 2, cross multiplication, solve the equation. 4 minus 1 is 3. 4 is equal to 5 plus Y divided by 2. So Y is 8 minus 5 is 3. For Z, 7 is equal to 6 plus Z divided by 2. So Z is 2 times 7, 14. 14 minus 2 times 7, 14. 14 minus 6 will be 8. So the coordinates of the point A dash is 2, 3, 3, and 8. 3, 3, and 8. Ask to get the point or the position vector. Find the position. So the position vector will be O dash. We can write it like this: 3, 3, 8, or write it 3i plus 3j and 8k. This is the final answer, simplified. Thank you.